of my talk again. And again, it's going to revolve a lot around ambush bugs, or I guess exclusively around ambush bugs. Before I begin, I guess I should tell you where I'm joining you virtually from. So again, for our friends in Australia, no, University of Victoria, not in Melbourne or anything like that. This is UVic, Victoria, BC, which is, of course, is in Canada, on Vancouver Island. So again, I moved here in 2019. So I'm very happy, really grateful to be living here on unceded territory of the Lekwungen speaking people of the Wasanich Songhees and the Esquimalt. And it's a beautiful, beautiful part of the world. And if you're ever down in this neck of woods, I would love to show you around. Let me just click an OK here on my screen. Sorry, give me one here. So just to tell you about where my background is. So as you'll see in a bit, or maybe perhaps I'm not, I wouldn't say systematics is my strength, though I do come from a lineage which does include the late and great Jeff Scudder. So, as we know, he was a giant in terms of entomology and especially Heteroptera in Canada. And of course, one of his intellectual descendants, Locke Rowe, was one of my co-advisors during my PhD. That's where I kind of, I guess, the synapomorphy of kind of what many of you guys talk about as those of us who are, we call what I think people ESA always called me an ecologist, even though I wouldn't call myself a very good ecologist. But Locke was my mentor, and as you'll see, he left a really big impression on me in terms of the way I think about science, the way I think about problems. Really, it's at the intersection of things like life history, evolution, and as you'll see, sex-specific selection. So again, I have dabbled in many organisms, many types of studies, many questions in my ongoing career. Ambush bugs have always been at the center of this, even when I'm not working on that system. So but I would say maybe less than half of the things I've published have been on Phimata, but they have always been, I think, the starting point for the things I've been thinking about. Almost all of the, I guess, the different ramifications of my research interests have always stemmed from, I would call it the whispers of secrets that ambush bugs have selectively, sometimes on occasion, shared with me. Okay, so for many of you, I think if you're from North America, you will probably have seen Phimata in some form. Well, I'm originally from Ontario. I spent about 2 decades of my life studying um, these critters here in my proverbial backyard in southern Ontario. So ambush bugs, as you know, are predaceous true bugs. They are marvelous in terms of their predatory habits. To begin with, again, they're predatory at all life stages. They're awfully good at the job, and that's what gives them their name. What got me interested in them, it actually started as an undergrad, and it started in a very simple place. Me collecting ambush bugs for my entomology collection, in a course-based collection, and looking in the field guide, and indeed seeing ambush bugs hidden among the flowers was really captivating. I don't know if you can see that on the right panel there, but that's an overhead view of Daucus carota, so wild carrot. You may or may not be able to tell that there are quite a few bugs in there, so at least going by the kind of conventional wisdom in my handy field guide, my Peterson field guide, this issue of green, yellow, offering some sort of camouflage, some sort of protection from visual predators, seems completely plausible. However, one thing that caught my attention immediately was pronounced, at least to me, sex differences in melanization. So what I mean is some elements being rather more developed, I guess, or darker in males than females, and some which also appear to have some sort of sex-specific expression. Again, if you think of what a penultimate nymph looks like, these are almost devoid of any of those brown pigmentation. So these are things which are adult-specific. Moreover, these are super variable among males. So again, to me, saying something is going on here, right? And so again, not surprisingly, when we're thinking about why males and females should evolve to arrive at separate phenotypes, I think it's not a stretch to think that there must be some sort of sex-specific selection going on. And again, something that's presumably happening at the adult stage is what I guess, I was first inclined to believe. So what do we know about sex-specific selection in nature? Well, I thought about coloration as also being something about, if you think of camouflage, is it from potential enemies? Is it from potential prey, right? So who are they hiding from? Well, long story short, I still don't know very much about natural enemies of bugs as much as I've tried to to I guess coax that out of this system. I don't know many organisms that want to eat these bugs. I've actually done really cruel things like tether bugs, paint them, put them places where birds visit, and nobody seems to want them. I've thrown bugs up into swarms, where basically during an ant mating flight, while there were a bunch of meadowhawk dragonflies going around picking things off. I decided to throw an ambush bug up into and got into the crowd, and it did get caught, but was promptly thrown right back at me. So it seems like they don't really have that many enemies, or at least I haven't been able to find them. More importantly, where you find them in nature doesn't seem to differ between the sexes, right? So females go where the food is, males go where the females go. So there's not really any obvious difference in terms of microhabitat use. So I'll tell you, I focused a lot of my attention on wondering what happens in the sex lives of these bugs. So uh, the one thing that I love about this group is when they are around, this particular population is a very big population. They are, as we know, bugs are not shy about doing things in the garish light of day in terms of their living their lives. You can mark these bugs. You don't get all of them back, but they do stay local for long enough to get some estimates of things like lifespan, lifetime mating rates, and things like that. Of course, I've studied them in the lab as well. I'm going to let you see, maybe you might be able to hear this. Hopefully the audio comes through. Up in the top left, there are some bugs courting. There's a male on top, and you're hearing that strange kind of sound, which is being amplified through laser vibrometry. So that weird kind of, phaser, Star Trek phaser sound is not the bugs themselves, it's because they're on a pin. Okay, so you're really hearing the transduction of of that vibration being transmitted down the pin itself. But nevertheless, they are noisy bugs. I think, if you know Christiana's work, these things do have a stridulatory apparatus like many other reduviids. What they're saying exactly, who knows? But again, I've spent a lot of time following bugs around, watching the soap opera out in nature going on in this bug population. You can stick little number tags on them. Once upon a time, my eyes were good enough to see or read Microsoft Word 2-point font, but that's about the size that they're on there. In any case, over the years, starting during my PhD, I've studied these extensively in natural populations. And long story short, it seems like sexual selection does offer some partial explanation to that melanic difference between males and females. So again, a very kind of local, a microevolutionary insight is that it appears that darker males um, often do gain some sort of advantage in terms of their lifetime mating rate in nature, though that does fluctuate considerably depending on ecological conditions. So the central panel, we're talking about how the strength of selection, this beta vector changes with sex ratio, changes with density as well. And interestingly, and somewhat obviously to me, they're also very temperature, I guess, how would you say, their mating behavior is very temperature dependent. I always think of bugs as being a lot like me, a little bit of a solar powered creature, right? So these things are really inactive at night or on cold days, but at certain peak temperatures, a certain kind of favorable temperatures, mating rates really spike. And that's what I guess, led me to thinking about, hey, maybe this color pattern difference is not something that's related to anything like mate choice and such. And I've actually looked for things like that and don't find any evidence that females care what males look like. It looks like where that advantage is coming from is simply through the thermal advantages of being relatively dark. Okay, so things I've done in the laboratory, you can corroborate that, yes, it does affect body temperature in a way that's non-trivial, even despite these being small animals, having really low thermal inertia. Nevertheless, if you manipulate a euthanized bug's color pattern, you can actually see that it does get darker faster, which is perhaps just a simple kind of corroboration of a simple expectation. More importantly, performance matters, or performance changes or depends on temperature and color pattern. So the central panel here under warm ambient temperature, what we see is there's not much difference among individuals regardless of whether they're light or dark males in terms of their mating frequency. In fact, everybody mates, does pretty well, and it's actually a flat relationship. But it's only when you chill things down to kind of morning Ontario temperatures where you see this advantage being revealed, where it's only the darkest males which are gaining mates. And again, half of the basically mating frequencies are cut in half, and only the darkest males are actually reaping the rewards here. So again, that's a partial explanation of why you might think that male coloration is being dragged upwards, right? But again, to explain the absence of it in females, what's going on there. Long story short, it's not clear exactly if there are any direct costs, direct selection against female color pattern. But one thing I can tell you is that coloration is costly to produce. It's resource limited. So a very simple kind of source, I guess, of limitations on the expression of, if you think of an unneeded solar panel, is, I guess what I'm imagining is that females have kind of done away with this or did not basically overexpress this because it's unrelated to what females are doing. Again, these bugs are primarily limited in terms of mating success by finding mates. Okay, mate search is the limiting reagent out in these populations or in this particular species. Hopefully what you can see is that, again, these are the same individuals, are exemplary individuals from high food and low food treatments and under laboratory conditions. If you feed things a little versus if you feed them a lot, right? And again, you can see hopefully on both the panel to the right as well as on the left that the same individuals do get darker, at least in terms of the asymptotic darkness, is really affected by high food. Long story short, a lot of food, you can build more of this solar panel, and if you're constrained by resources, then you cannot. Okay, so it seems like at the very least that this is something that may be favorable for males, at least for some aspects in terms of mating success, but it's hard to do so. It's energetically expensive. So that is at least hopefully a partial explanation for why perhaps females are underexpressing this. Interestingly, if you think about, again, thinking about how males and females are being tugged into in different directions in terms of, what natural selection is demanding from them, what we see is that food manipulation actually has a negative effect on male survival, but has a positive effect on female survival. So what I'm interpreting this as, what we're seeing is that males are dumping more resources into this component that is favorable for one aspect of its fitness, right? So mating success, but doing so perhaps at the expense of longevity. Okay, so again, completely in line with some of the theories I was chasing in terms of sex-specific allocation to different life history strategies or different components of fitness. So hopefully I've convinced you that at least this is the backstory, that there is something going on that I can at least partly offer some insight into what has gone on in this particular species. Again, and central to that is thinking about sex-specific demands, right? So again, the way I envision it is that males are allocating limited resources to in a different way than females, and whatever it is in that sense. So in this particular case, perhaps if we're talking about mating success being linked to that thermal secondary sex trait, then perhaps this is a decent or reasonable partial explanation for that phenomenon. Now, that's a microevolutionary view, a one species story, but as we know, if you look across the genus, there's quite a bit of variability. If you think about, the degree of melanism when you see, from the kind of dorsal aspect versus the lateral aspect, and what's going on there? So to me, it wasn't enough to just say, well, I kind of understand something about this one species. I really do seek some more general explanations for the diversity we see at a macroevolutionary timescale. So again, to put things into perspective in terms of who I was introducing you to, Phimata americana here at the top. Well, again, these are, at least if you take INAT at its word, which obviously you need to take with a grain of salt, given that there are a lot of these, I think, doubtful observations here, but Phimata americana is pretty wide ranging. Okay, so again, notice the difference between Phimata americana and, let's say, Phimata pennsylvanica here. So notice that females do express, and they do so considerably more than most other species in this genus. What's going on there? Now, I should also point out that Americana and Pennsylvanica are pretty close phylogenetically, right? So, and if you think geographically, their distribution of Pennsylvanica is about here in the northeast, right? So they do overlap quite a bit a little bit in range, and some of my other work has shown they actually do hybridize or readily hybridize, and probably are a bunch of there probably is a moving hybrid zone across the continent, or at least that part of the continent there. So, but what's going on there? Can I explain what's happening here? Honestly, this has been a challenge. It's been a thorn in my side to on one hand, I feel like there's this nice canned story, and then right to the south, there's this other species, an interbreeding species even, which does something completely different and does not seem to make any sense to me at all. But what do I know? I've studied the life history of both of these species just because they are very accessible to me. I can tell you that there are a lot of different lot of detectable differences, divergences, or let's say divergent life history traits between these populations. But how is that related to melanism, I guess, is the question. How do I chalk up this female melanism to anything that's semi-sensible? I guess where my brain started to wander was into this world of thinking about insect immunity. Part of that was through conversations with mostly Drosophila genetics people who were pointing out that in some of these model organisms, melanism is tied to immunocompetence or immune response. And the basic, I guess, the underlying idea here is some of the precursors of melanism, basically this phenol oxidase, is part of this pathway, and it's supposed to be resource limited, and basically standing amounts of phenol oxidase in some cases have been linked to I guess the overt kind of expression of melanism. So you could think of melanin being perhaps correlated with your standing kind of resources in terms of your ability to withstand some sort of pathogenic attack. Okay, so that's kind of, there's been a lot of work in that field suggesting that perhaps this is a promising part of the story that could be added to maybe explain some of these differences that I've been seeing. And again, not surprisingly, investment in immunity too seems to have diverged between sexes across metazoa. So again, one of the things that I'm basically adding here is asking, well, this female-male difference, right, in terms of how they allocate could also differ depending on which species we're talking about, right? So different species might have a different male-female game, different sorts of trade-offs. So that's something that I'm set out to hunt down with a colleague of mine. So that's Roz Murray at the University of Toronto, Mississauga. She's somebody who does a lot of work in insect immunity. So we thought we'd team up and really ask a really simple question and ask something about how immune responses might vary between sexes as well as between species in Americana and Pennsylvanica. So my primary hypothesis was that melanism was going to correlate, was going to map on essentially to the degree of cuticular melanization that we see in adult bugs. And secondarily, my expectation was that immune defense might be also mediated by the amount of resources available. So again, in a very simple laboratory kind of experiment, one thing we could do is just manipulate food again, right? And see whether that too is going to affect the ability to mount an immune response. So what do we find? Well, I should tell you what we did first. So again, two species here, and really simple high-low diet thing like I had done before. Quite easy to measure cuticular melanism like I always have before. And the difference here in terms of what we're looking for in terms of response is how bugs of the different sexes and different species and on the different diets we're going to respond to a simulated pathogen. So again, we're talking about like an actual, think of something that's mechanically kind of embedding. So I'm thinking something ectoparasitic or something like that. Okay, so in this field, many people simulate this as in a very simple manner, is really just injecting a tiny bit of monofilament fiber into the bug, in our case, into the abdomen, and then 24 hours later, see how much melanin was deployed to basically, gum up this simulated pathogen. So it's a standard, one of the standard assays in insect immunity. So did it work? What did we see? Well, we didn't see very much. Again, to orient you here, encapsulation response. That's the amount of melanin deposited on the y-axis here. And again, we've got the species Americana and Pennsylvanica on the left and right panels, respectively. And again, of different food treatments and different sex. Okay, so again, without going into too much detail, hopefully what jumps out at you is that nothing is going on, right? So in short, no, we got shut out on this one, where we didn't find anything that mapped on at all into sex and species differences in melanism. And resource availability itself didn't seem to offer any, or didn't seem to modify that at all. So we were a little bit disappointed that the work, and not surprisingly, has been kind of in prep and kind of spinning its wheels. And I guess journal of negative results, here we come. But nevertheless, one thing it has told me is that immunity might not be part of this story. Okay, so this is where kind of life and getting jobs and things like that interrupts things. So, I moved away from my proverbial Ontario backyard in 2019. I got an adult job out here on Vancouver Island. So again, it was fantastic for me and my family. And so, but I had to leave my old friends in Ontario behind, at least for a little while. The first thing that when news gets out is all your colleagues from around the world start emailing you, say, "Hey, dude, I heard you got a job. That's awesome." And then they're like, "Wait a minute, are there ambush bugs in Victoria?" Was one of the questions. The other question, "How's life out there? Are there any interesting phimatids out there?" Well, to answer the first question, no, there are no ambush bugs in Victoria. At least there shouldn't be. There are some strange anomalous records that I can find around, which I still don't understand. But I beg my undergraduate students here to let me know if they do find them. And there's never been a sighting since I've been here. In terms of are there any out here at all? Well, not here, not on the island or the Gulf Islands and surrounding. But if you go a bit farther east, there actually is this species. I guess I think we recognize it as species. I don't know if Paul is here, but yes. So if you go into the interior BC, there is a species called Phimata metcalfi. Notice what goes on here. Males have completely, apparently, dropped that lateral melanism. So again, like lucky me, because I'm always getting access to these strange outliers, I think, which I'm hoping could be models for understanding kind of the group in general. So the task for me was to go see if I could get some of these. And indeed, this is one of those things which really helped, mining museums, and specifically specimens contributed, I think, collected and ID'd by Jeff Scudder, right? So I think the lore is that Jeff Scudder, that he had a property in Osoyoos, which is why a lot of material that I find in museums comes from him. And so I knew that going through my own museum mining or data that I'd collected through various museum visits. And so while my family and I were driving across from Ontario to Vancouver Island, of course, and I'm sure many of you in the room do the same thing, plan your family life through around good bug collecting spots. And so we stopped in Osoyoos for just a day, but I knew I had a feeling that I'd be able to grab a few based on Jeff's observations and his specimens contributed in my data set. And sure enough, I was like, oh, this is awesome. So we do have them. And so the plan, I guess, is to take the ambush bug show on the road out west and see if I can get back to doing some of the things that I know. I don't know what happened here. Anyway, that is the hope. Now, I have nothing really much to offer about these guys. I have managed to rear some of these things up under laboratory conditions, which is promising. So I'm hoping to have more to tell you in the years to come. So that was my plan. Now, without telling you anything substantial, one thing I can tell you which shocked me was during the rearing of these bugs, things were kind of proceeding the way that I expect them to go. So I apologize for the bad pictures. I'll show you why. I'll tell you why they're bad in a second. And if you can see that, again, these are representative images of males at 10 days versus quite a bit later in life. And notice that for some individuals, some males are shockingly dark to the degree that I've never seen in museums, and I don't know what's going on there. Immediately, I wrote Paul Masonic and said, "Hey, have you ever seen this before? Have you ever seen specimens that look like this?" I think well, basically, assuming I'm paraphrasing him correctly, he said no. So what on earth is going on? I have no idea. I apologize again. Maybe these might be better or worse in terms of of kind of making that a little bit more visible. My point being that I was not expecting to see any melanism expressed because I had never seen any thing like this in museums myself, nor with the adult bugs that I'd collected. They expired on their own. Don't know how old they were, but I'd never seen them develop that. But these are the F1s, so the kind of first generation lab reared males, and they're expressing. And why that is that notable is, why are the photos so bad? Because if you recall, in about summer 2020, at least up here, this is what people's labs look like. Where it was like every corner of my house had bugs and weird stations, and I did not have access to a proper imaging station at home. So I had one of those really awful Amazon USB kind of digital cameras to see if I could get anything. Anyway, it is what it is. But the point being, yeah, there's something strange going on. And why is that surprising? Well, first, don't know if it's surprising. I don't know if it's even biologically significant, because if you think about how old these bugs are, at least based on if they're anything remotely like Americana, rarely am I going to mark a bug that lasts longer that I've seen come in beyond 30 days. So this is really late in life. So what's the function? What's the importance ecologically? I have no idea. But you know, just from a very simple level, I didn't even know this was possible, honestly. Because if you think about what happens in Americana, the figures I showed you previously, there is ontogenetic change, but it usually maxes out after about 7 to 10 days, and they don't get much darker after that, right? They'll darken a little bit, but not to this degree. Pennsylvanica is even more, again, one of those things about Pennsylvanica, what's amazing is as soon as they emerge into adulthood, within 24 hours, they're already laying down a lot of dark pigmentation, whether they're male or female. So seeing something like this was super surprising. The conventional wisdom, at least that I was reared up under, was that during the teneral phase, that's when melanin is being deposited, and after you get to some certain point, you just can't really add much more unless you actually scar or break the cuticle, and that's essentially what the literature had told me, that there's that. Melanization is a time-constrained process. It's a chemical thing. So, if any of you can explain to me how this is even possible, I'm all ears. Okay, so any case, I think I will be should be running out of time pretty soon. I think I already am out of time. So just some general takeaways. I guess I didn't not very much a takeaway in terms of a general explanation, I'm afraid. That's still something that I'm chasing. I wish I knew. But one thing that has been fun with working with these bugs is they seem to always, you know, they surprise me constantly, right? And so obviously there's a lot left to do. And yeah, I do hope to get back to working on Phimata. One of the problems where I live now, and I'm sure many of you unfortunately know that or experience the same thing, is fire seasons have been early and long, and where I need to go is in the fire zone. So my pre-pandemic plan was to be doing field work in Osoyoos area every summer, but has been, let's say, challenged by our situation in terms of wildfire seasons. But I'm going to keep my fingers crossed. So with that, I will end there, and I would be happy to answer any questions if I have any time, or maybe at the end of after Christiana's talk. Thank you very much for your attention. Oops, I can stop